Hello, everybody, and welcome to TBS Tech Trends with me, Boyan Stirov. I'm here with Boyan Stirov in our first episode, and we're going to talk about how software is getting into the network. I remember when I started back in the day with CCNA, it was a huge trend back 15 years ago, and now I see that the software is kind of redefining that space.
Yeah. Well, I would say that it's a bit of a marketing thing to call it software-defined networking in general. I mean, the first time I heard about this was more than 10 years ago, so more than a decade. And to me, it's a kind of a strange name because from the very beginning, let's say since the 80s, the software has always defined the data networks.
Yeah.
I mean, and it's kind of ambiguous, but it has a meaning. It has a meaning because the idea is that with software-defined networking, the new trend is to have more centralization, more automation, more visibility what is happening within the network. And all of this, I mean, all the major vendors that are providing software-defined networking products, doesn't matter from what kind of product it is, those are the general trends. And the idea is that you usually get this packaged in one whole solution. So you get it from day one since you deploy it. Because, I mean, it has always been possible to have automation that you can do yourself. But then if it's not something that comes from a vendor, you have to do it yourself, you have to support it yourself, you have to develop it yourself, you have to do all the changes. So yeah, for some organizations, that's perfectly understandable and doable. But for large-scale organizations, they expect to get such a solution from a vendor. And that's the general idea. Now, the biggest trends are maybe the biggest trend right now is with software-defined wide area networking. I think that probably in the future we are not just going to call it software-defined, it's going to be just wide area networking because this is primarily nowadays the most installations in that area of networking are some sort of software-defined solutions. And the benefits are great because you have automation, as we said, you have centralization of all the management, you have better visibility where the traffic is going, and because this is generally a solution that was originally targeted for the big markets, where you have companies that have hundreds of thousands, sometimes locations that they need to interconnect. You can have a lot of savings in terms of monthly bills you have to pay to the carriers, because when you have this better visibility and automation, you can have much more intelligent and much more complicated schemes on how you route the traffic over the carrier, so that you can save on the monthly bills, and potentially you can have general purpose internet used as a connectivity between the sites. You can also have backup over mobile network. And again, of course, those are things that were available much before software-defined wide area networking became a thing. But nowadays, it's much more easier to deploy such a solution, and you can really start from day one. Because what I have seen from my experience in the past is that, I mean, network management systems were always lagging behind. So the first push is to deploy the network, to have the connectivity, and then it was always like an afterthought. And the other thing that has always bugged me is that the network management solutions by themselves were very expensive. I mean, you probably remember the days of HP OpenView.
Oh, yeah.
Extremely expensive product.
Still used, by the way.
Yes, by the way, still used. and probably it will be used for some years to come. But even the other vendors, it was, and this is something that you pay just for the network management system in terms of licenses, and then you still have to pay for the carriers, for the routers that you have. So it was, I mean, most of the time for smaller solutions, what we have been normally using are network management solutions with low feature set, which are cheaper, or even open source products, and this is how you get by. Now, the whole idea of software-defined wide area networking is that you get a package. You get the package, and from day one, you start to use that centrally.
Does this mean that, for example, this bundle and this idea of software-defined networking and having this holistic approach means that these features that are previously quite expensive, like those big NMSs like OpenView, are now available to more, let's say, mid-size to SMB customers?
Yes, because the software-defined wide area networking as a product is very well positioned, and it has many use cases where you can have your tenant into the vendor cloud. So you pay your monthly fee, everything is pre-set up. You can even use something that is called, all major vendors are supporting that, it's called zero-touch provisioning. Zero-touch provisioning means that you can get the new device, you send it over with a courier, for example, and then the local staff just unpacks it, plugs it in, and automatically, at some point, if they connect it correctly to the wide area network port where it has internet access, it reaches some helper site. It looks for a specific DNS, and then it goes and it is recognized, and it goes into your tenant, and then you can start managing the device, which is very convenient, especially for customers which have many locations, so that they don't need to send specifically somebody on site, field technician or maybe a networking technician to set it up. And of course, this works if you have public internet access, because if you don't have public internet access, in general, it doesn't matter the vendor, you cannot use zero-touch provisioning.
So this sounds like a very nice thing that all the, for example, routers in the example that you gave, is they're like sparable endpoints that you can, if something happens, you just unpack one, and you don't need to do any migrations, you don't need to do any configuration, you just plug in the internet and it will download the whole configuration straight away.
Yes, because the centralized component, whether it's in your private cloud infrastructure or in the public cloud infrastructure, which manages the whole stuff, by default has configuration management. So the configuration is created, edited, and managed on this central component before it is pushed to the device. So it's pretty much the same concept like with the public cloud, where, I mean, I read it somewhere that in the past, you have a server, physical server, usually you call it some name, Zeus, whatever, and you treat it like it's your pet. And then when you go to the cloud, you treat all the loads there like they're herd. So you know how many there are, you don't care how many there are, the only thing you care is that you have service that never stops, and you have this flexibility to increase its capacity. And the general idea here is pretty much the same, because you have the centralized component, and then if you have enough capacity on the centralized component, you don't really care how many are the endpoints, how many branches you have. And of course, yes, the configuration that you may end up might be very complex. But again, once you create it, again, you don't care too much, because you can always recover a device that fails. You can always change the config en masse. Again, this is another big component here, that because even for big organizations, when you have end devices like these SD-WAN routers, usually they have in their configuration a lot of things that are the same. And another thing that is very common with SD-WAN deployments nowadays is that the configurations are built in such a way which pretty much resembles the approach that the programmers have, because you have the configuration commands that are built into the configuration file, but you also have variables that you can set up. And this is important because when you look at the router configuration for the wide area network segment, you have many things that are absolutely the same on many devices, but you have host names which are different, you have IP addresses which are different, and this is something that you have to take care of. And one thing that we have discovered through our past projects with SD-WAN, especially Cisco SD-WAN, is that this is very important step when you plan the deployment. Because the biggest gain that you have using SD-WAN product is if you look at your current environment, your current wide area network infrastructure, and you have to check whether you can make the configurations in such a way that they have as little differences as possible, because this is how you can take advantage of reusing the same configuration of objects that you put into the configuration file. Because if you treat each endpoint as an individual router with completely different configuration from the others, then you're not gaining that much, because you have to afterwards manage all these different devices separately. You will not be able to have this en masse configuration.
Yeah, I think it's really that similar to the concept, for example, of those infrastructure as code components like Terraform and like Ansible.
Yeah.
So you need to have a good understanding of the configuration. You have to do a little bit more in planning. Then in the end, it actually gives you back into day-to-day operation, into everything afterwards.
Yes.
But also, when I'm hearing this from you, I'm thinking about other, how should I say, another challenge from not only from the past, but even currently, about auditing and configuration drifts.
Yes.
If you have this centralized approach, then you don't have this issue.
Yes, because all the major vendors, once you have built and deployed the configurations, you can do reports, you can compare different versions of the configs, you can compare with other devices that you're managing. So it's normally built in, and it's the way it should be. Like in the past, the big and expensive NMS systems that we have been using and still use in some situations, they also have this feature. But again, it's not because the NMS so far has been like a third-party product.
Yeah.
So it has usually many features, but when you depend on a third party, you pay additional licenses, and of course, because the product is like bolted in, very often you need a separate skill set to work with the product, to manage it, to operate it. So here with the SD-WAN especially, the approach is that you don't need separate skill set to work with this solution. If you're a network engineer, you work with SD-WAN. You don't need somebody that is just managing the controller, that is controlling everything.
I remember we were joking in the Microsoft world about SCOM, Microsoft System Center Operations Manager, because it can become so big that you're not only managing the environment with it, you're managing itself. So it's becoming a problem by itself that needs to be actively managed and looked after. I can imagine that. We are, and I guess now even with the cloud, the concept of SD-WAN is really gearing up as well. Because if you want connectivity, the cloud is like your third data center. So pretty much SD-WAN is a solution that can.
Yes, because everybody is talking public cloud, private cloud, but in reality, at some point you need to mix them. So hybrid cloud is probably the thing that the biggest companies will be using, even multi-clouds, but then the bills will be doubled or tripled. But anyway, again, your public cloud infrastructure, the tenant that you're using in the cloud, you really have to treat it like a separate data center, even though you don't own it.
Yeah.
But then this means that you have to deploy a component within this tenant that provides this secure connectivity with the rest of your environment. And then every major SD-WAN vendor is providing that. I mean, you can even, for example, Cisco, they have partnership with the major public cloud vendors. So you can deploy the virtual machine that represents the edge router from the marketplace of the respective public cloud vendor, and then interconnect it with your controller, and then start deploying configurations, and then you can make logical connectivity with the rest of your infrastructure.
Yeah, from my experience with public clouds, I see that the companies, they start, dipping into the public cloud. They're starting to adopt it, like doing test, dev, and so on. And initially, when you start doing that, you're not thinking of how this is integrating in my whole environment, how this is integrating in my networking, how the whole network solution will ensure that that security, that level of performance that I need when I start to move that workloads. And then in some point in time, when they started migrating business critical workloads like SAP and so on, they are starting to get that issue of how to do the networking part correct, how to do it in a performant way, and so on. So this is something that is
and in general with the SD-WAN, it's very flexible, because once you have connectivity, once you start managing centrally all the edge devices which are interconnecting different parts of your network, you can, I mean, within the WAN segment, you can do different overlay networks. They call it usually VPNs. I mean, you can segment the traffic within your WAN segment. You can isolate it, segregate it, so that you can achieve different logical topologies within your WAN segment. And it doesn't matter. Again, the main idea is to have like an abstraction layer on top of your carriers. It doesn't matter the carrier, whether it's MPLS, public internet. I mean, we usually say it doesn't matter. It always matters, to be honest, because if you have a crappy carrier, you have crappy service, whatever you put on top of it. But if you have normal carriers which are not having too many packet loss, too big latencies, I mean, very high level of jitter, you're usually fine. I mean, and again, this ability to really put an abstraction on top of your transport is a very flexible concept. And of course, this is not a new thing. I mean, it has been available many years before SD-WAN became a thing. Because previously we have been using tunneling, which is configured either manually or just through some sort of custom automation for configuration deployment. Cisco has been very successful in the past with their DMVPN technology, which is dynamic multi-point VPN, which basically means that you have a hub or several hub routers, and then your edge devices, they can dynamically form secure tunnels between them and overlay the traffic on top of the transport network that they're using. And it's still something that is being used. But again, I can speak from my example, from my experience, for example. It's extremely, when the size becomes large, it becomes very complex to manage, operate it, and even introduce some changes. Because if you don't have a good automation solution that can help you with this, and even if you have custom automation solution, it's probably built with specific use cases in mind. So if the use case changes a little bit, you need to find the guy who has prepared that custom automation and fix it. So basically, the idea of the SD-WAN solution is to assist you in all this, and to make it in such a way that the scale is not that big of an issue. It's always scale is always an issue. But in general, you shouldn't be caring that much. And of course, in our region, the scale is usually not that great. And the benefits are very substantial, in my opinion.
That's very interesting. And when we are talking about software defined, we talked about the software defined WAN, but Can we talk about software-defined access?
This is how Cisco is calling it, the software-defined access. The different vendors have different names, but basically it's the same concept. But the area where this is being used is in the local area network segment.
Okay.
I mean, the local area network segment has for many years been lacking the level of management and automation because, I mean, in many situations you have a bunch of switches, you interconnect them together. If it's a small organization, you usually have some trunks between them and you interconnect them layer 2, and you have probably one central switch. So the collapsed core architecture is very popular nowadays. And in the past it was also very popular. So if it's a bigger infrastructure, you might put some distribution switches to scale the topology. But in general, usually the idea is that you deploy that, you configure VLANs and trunks and port associations, and then once you start using and operate that infrastructure, you basically change some port associations here and there. So it's a very rigid, not very flexible infrastructure. And one of the things that I have been also thinking in the past is that even if you're a network engineer that has built that, you don't have a good visibility what kind of traffic is passing through that network. Because it's like you provide the pipes, so to speak, on where the traffic will be flowing. You interconnect them, you make all the interconnections and everything runs, but what exactly flows through these pipes is unknown. And this is something that has always been a pain point between the network engineers and application engineers, because I mean, as a network engineer, you'll be like, okay, my ping works. I mean, this here is fine. But then from an application perspective, it might be that a particular application is really suffering to pass traffic through that environment. And then
I can think about voice.
Voice. Yes. And again, this has been a problem for many, many years. I think originally what we have been using to solve that is to put more capacity to the rescue. And by the way, it works. In general, I mean, I remember the first, I was visiting a quality of service course many years ago. And then I remember the instructor said that, I mean, every issue that has quality of service problem, you can solve it by putting more bandwidth. And we can see that in the Ethernet segment, I mean, the speeds have been growing almost exponentially in the past years. And this really alleviated the problem, because if you were using 10 megabits per second Ethernet port, then you go to 100 megabits, then you go to 1 gigabit, which is, by the way, nowadays expected and standard for an access port. Then you go to 1 gigabit for uplinks, and 10 gigabits, 25 gigabits, 40 gigabits, 100 gigabits. I mean, you have a lot of capacity in the local area network segment. So this has been for many years been overlooked. But again, when you look at it from a security perspective, if you try to understand what applications traffic is flowing through your local environment, because this is something that you own, this is something that you usually have some sensitive information on the file servers, or you're using some business applications that you're managing, then it becomes a great deal to understand what exactly is flowing through that environment. So all the software-defined solutions in the access segments, they're also trying to resolve that, to give better visibility what is the traffic, and they have a great deal of engineering, and some vendors are putting machine learning and some even claim artificial intelligence algorithms, which are able to deduct what the type of traffic is flowing. They can take the baseline of the system. So this is the normal state. And if there are any high deviations from the baseline of the traffic that is expected to go through that environment, then you might get an alarm. Somebody has to look at it. And the other thing, again, if we talk about security, and I mean, you cannot talk about cybersecurity without network security.
Yeah, of course.
To me, that's why the cybersecurity subject is so diverse, because everything matters. I mean, you cannot say network security is more important than anything. everything is important.
Exactly.
But network security, in order to achieve that into the local area network segment, you also need a lot of automation.
Yeah.
And I remember I was reading an article years ago that most of the network breaches were done not because there was something wrong and there were vulnerabilities on the devices, but because the security configurations were not consistent enough throughout the whole environment.
Yeah.
And then if you have centralized component where you build your templates, you build your configurations and then push them everywhere, it's much easier, much more achievable to have consistency in the security configurations. And on top of that, with the software-defined networking into the access segment, you also have different technology mechanisms. I mean, it's a different way of how the traffic is transported and isolated within the environment. Because in a standard layer 2 switched network nowadays, I mean, if I'm able to gain physically access to a port which is not secured, I might be able to gain some access. I might be able to sniff some packets, some broadcasts, some multicast packets, even unicast packets. And the software-defined solutions, they provide technologies which are isolating the traffic from the different ports in much more flexible way. I mean, the types of technologies that are used underneath are usually, they build a fabric, an IP fabric. IP fabric means that the interconnections between your switches in your local area network segment, they're usually not using layer 2 interconnects, they're using layer 3 links. Then they start a routing algorithm which routes that traffic, and then in order to pass layer 2 frames from one port to another switch, they do automatic tunneling between the switches. And usually, I mean, Cisco, for example, is using Lisp and VXLAN tunneling, and this is how they And again, when you have this type of tunneling, you can also very strictly isolate the traffic, and you can have much more segmented and segregated traffic within your environment.
This is a very interesting topic about the visibility of the network, because when we are, for example, in the public cloud part, which is more into my expertise, when we're starting to try and plan for a workload to be migrated, the network traffic is always a black hole.
Yes.
Because it is a thing that you are actually paying a lot, because if you move a workload over to the cloud, you need to think of how the users are going to access it. You're paying for all the outbound traffic from the cloud. And almost none of the customers know how much this means when you go there and ask, okay, what is the traffic that is generated by your SAP system? And because if you have something like you said, like SD access, you can see, okay, I have X amount of traffic, and you can properly calculate it and do your return on investment of that move. But if you don't have something like this, and in most cases you don't, you're flying blind. So you just move there and just see what happens in terms of networking, which is especially when we're talking about systems like SAP, is not the best move, pretty much.
And it's again something that is not entirely again a new concept.
Yeah.
I mean, SNMP has been around for many years.
Oh yeah, that's true.
But nowadays, the vendors, they prefer to use something that is called streaming telemetry, which can provide way more information than SNMP was ever meant to provide.
And SMMP was also complex to implement.
Yes.
You need to go device by device pretty much, or if you have some
and you need
centralized
to have
and
compile the
NMS,
MIPS and have object IDs, which
it's something that it's not the SMB company, in our region, probably it's not going to look into that. It's going to be way more complicated. So it was reserved kind of for the big companies. But what am I hearing is that, like in other areas, software is making things more accessible to smaller companies, and actually providing more and more information and making it um, making it cheaper and accessible to have enterprise-grade deployments for SMB.
And of course, I mean the business models are changing in that regards, because with SD-WAN, SD access offerings, you might get it as a service. I mean, you can have the controller into the vendor cloud.
Yeah.
You get your access there. You pay for the amount of devices that you will be managing, and then you're up and ready to deploy.
There's the future, being flexible.
Not in every environment, of course, because if you're a government or a very strict and secure organization, you might have some regulations which prohibit you to use public services. But again, the major vendors, they also provide options to deploy the controller components within your environment. But then again, the complexity then rises, of course, because first of all, you need to provide the compute and storage resources. Then you will be solely responsible for all the management, monitoring of the deployed virtual machine that is the controller component, and all the backups. You have to make sure that you have regular backups, because otherwise you might lose the controller. So, but again, for big, strict, very secure organizations, usually this is not an issue, because they probably already have this infrastructure ready. They probably already have a backup and restore team that is ready to add another component that they need to manage. So it's usually not a problem.
And when I'm hearing from you, I'm hearing a lot about vendors. I guess those deployments of SD-WAN and SD access are vendor specific, right? So
yes.
So you cannot just mix and match.
That's true. And every customer out there has to be aware that when they choose a vendor for SD-WAN or SD access, it doesn't mean that you cannot 100% interoperate with the other vendor device, but it's going to be in like custom type of configuration. Okay. So for example, if you have an SD-WAN edge router, which is managed by a controller, you can configure that specific box to build an IPsec tunnel with another vendor. You can do that. You can perform the routing, but it's going to be this custom type of configuration.
You're losing the idea in the end of the day.
Yes. So it's not impossible, but it has many specifics and many things that you have to look through before you attempt it, because there are many dependencies, what is supported, what is not. And to be honest, I mean, the networking in general throughout those years has been has had a very good track record of interoperability. I mean, to be honest, I mean, that's the reason why we have the public internet.
Yeah, that's the reason.
I mean, if we didn't have those protocols which are implemented by different vendors, they're recognized by different vendors, but this still stays. I mean, with SD-WAN and with SD access, we are not changing the networking segment entirely. We are still relying on IPv4, IPv6 if it's needed. We are still relying on Ethernet as a layer 2 framing mechanism. So the thing that changes is that you have the possibility to really have this abstraction of your transport environment and to build different logical topologies on top of it.
This means that when you start thinking about this type of SD access or SD-WAN or anything that is SD, you need kind of a more strategic vision in terms of choosing a vendor and sticking to it to get the full benefits of the whole thing. Because
generally yes.
Because I guess you can do a multi-vendor approach, but then I think this is going to be first, it's going to be more expensive, and then second, you lose those type of things of benefits of having a single pane of glass of the overall network environment.
Exactly. At least how the things are available right now, this is the situation. So, I mean, you have to choose the SD-WAN vendor. I mean, in the different segments, the vendors might be different. So in the access area, you might have different software-defined vendor for that segment. In the SD-WAN, it might be different. But again, within the segment that you're deploying this solution, it's, the biggest benefits and the biggest return on investments, if you will, you'll get it from the vendor that you choose. And of course, you have to really look at your business objectives look at what you're trying to achieve. I mean, I think that many times we are doing these mistakes because we are thinking that, with great technology we can solve any challenge, which is not always the truth, by the way. I mean, you always have to look it from the requirements of the organizations. What you're trying to achieve, what problems you're trying to solve, and then you have to look at what the vendors are providing for this, whether it's vendor A, vendor B. But then you have to look, and I would suggest that the biggest vendors, they also provide some sort of proof of concept, proof of value, sometimes types of demos that you can play around. If you're a big customer, they can probably arrange such demo in your environment. I mean, Telelink is an organization that in some situations can facilitate that.
Yeah, I think we did some
we have done it in the past. So I think this would provide really a grasp of what you get with the solution. Because, let's be honest, there are a lot of, in the networking space and in every, big tech area, you have a lot of marketing.
Yeah, that's true.
And it's not necessarily that they're saying or lying, but sometimes there's specifics and dependencies which are not obvious, to put it mildly.
I know what you mean.
Yes.
I know what you mean with that.
But in general, I think if you can arrange a proof of concept, proof of value demo that you can use, you can get your hands dirty with it. You can really get a sense of what you're getting and whether this is solving the problems that you're trying to solve.
I think probably an interesting mind shift will be because probably in the big enterprises, they're familiar with that concept, getting a vendor, kind of sticking to it, and so on and so on. But with this level of a software-defined access and WAN coming down to mid-size and SMBs, maybe there will be some culture shift when the switch it's no more just a switch. So you cannot go to the store and just buy another switch and so on and so on. So it's kind of a little bit of mind shift of you getting more, more into business requirements, more into long-term planning to get the real benefits, to get the best bang for the buck, and fully utilize those things.
And then in the end of the day, if you're even a small or mid-sized organization, at the end of the day, you have to think to yourself, what part of my business processes really required stable, reliable, secure connectivity? Because there are probably some organizations for which this is not a strict requirement. So maybe you don't need to invest that much. But if you realize that, what happens if your networking is suddenly not available? What happens if your wide area network that you have built is suddenly not available? What happens? Maybe nothing, but maybe it's a disaster for the whole business.
Every time now when I'm listening to you about unstable connection, the first thing that comes to my mind is Wi-Fi. I have seen a lot of customers, a lot of even enterprise level customers have challenges with that.
Well, maybe the first thing that we have to establish here is how enterprise grade Wi-Fi differs from your home Wi-Fi.
Yeah, that's great. Great point.
I find that many people have unrealistic expectations or wrong assumptions about this, and it's first of all, Wi-Fi is something that I adore, to be honest, because I think it's an amazing technology. It has been developing at a rapid pace through the past decades, but it has some specifics that you have to be aware of. Now, first of all, in general, if you take your home network and the enterprise network, technology-wise, from the Wi-Fi perspective, they're the same. I mean, sometimes even if you're buying a more expensive home access point or a router with Wi-Fi, you might get better technology than the company access point.
Yeah.
Why? Because, I mean, the company, the enterprise access points, they don't have such cadence. I mean, the release
refresh cycle,
the refresh cycle is longer. Second of all, they're more expensive because the way they're built, the components that are used, they're more durable because the vendors that are selling them for a lot of money, they need to prepare them to be as durable as possible. Otherwise, they have to replace them. And then the vendors that are building access points for the home users, they can use cheaper components.
Yeah.
That's for sure.
Yeah.
Why? Because, I mean, they can get away with it. That's for sure.
Pretty much you're changing your Wi-Fi every 2 years. I don't know, something like this.
But in general, technology-wise, the Wi-Fi that you have at home and into the enterprise, it's the same. To me, the main difference is, first of all, how you are managing it and what kind of security you are able to apply. Now, where's the difference here? Usually the enterprise Wi-Fi deployments nowadays, they use centralized management with a wireless controller. It's pretty much the same concept that we talked about SD-access, SD-WAN. I mean, it's like software-defined Wi-Fi. And by the way, for many vendors, including Cisco, the Wi-Fi is usually packaged with the software-defined access. So you can directly control the Wi-Fi from your software-defined access controller. So this is a very important requirement because because normally in an enterprise you have a lot more area that you need to cover. So single access point is not going to work. So you have to use many. Usually this is called the so-called carpet coverage. So you take the floor plan, you start putting the access points and you try to cover as many as possible. The current trend and the current best practice is to put more access points, use them with lower emitted power so that all the hosts that are near the access point, they can achieve the fastest possible speeds they can achieve. It's more expensive, of course, because you need to put more access points. So it's a kind of a trade-off between what kind of money you're ready to spend and what kind of performance you're getting. And then in the home environment, some people, they have big homes. You still can have more than one access point, but usually you don't control them centrally. New home solutions nowadays are starting to provide that. But to me, the biggest difference still is how you authenticate and authorize to use the network. Normally for a home environment, you're using a pre-shared key.
Password.
And I mean, in general, from a security perspective, if a secret is shared, it's no longer a secret.
That's true.
And by the way, if you have the pre-shared key, if you have captured the traffic, which is encrypted with the pre-shared key, it's much more easier. You can decrypt the traffic if you have the pre-shared key. But in a home environment, that's normal because in home environment, you don't want to have an additional server for authentication authorization. You probably don't have it. You probably don't want to set it up. But in an enterprise environment, that's extremely important because having centralized authentication authorization provides you with the ability to have different encryption key for every different Wi-Fi host that is accessing the network. So if my host is compromised, I can exclude it from the network.
You can isolate it.
And I will not compromise the security of the connectivity with the other hosts. And again, the high-end enterprise-grade Wi-Fi solutions, they also provide different ways. The golden standard for security in Wi-Fi is to use TLS encryption. So basically, you do not authenticate with the password, with your username and password for the Active Directory. You can, of course, integrate with external identities, service. So this identity service, for example, in our environment at TBS is the Active Directory.
Yeah.
So I can use my credentials for the Active Directory to access the Wi-Fi. And in any other office that I go, any other TBS office that I go, I can use the same credentials. So I don't care whether I'm in Macedonia, whether I go in Croatia, whatever. But then you can also use certificates. And these certificates, in our case, it's easy because we have internal PKI. So we can generate a certificate for every Wi-Fi user. But again, if you use certificates, it becomes, of course, more secure.
Yeah. Not only that, we can integrate it with our MDM solution. So in that sense, when we have a host which is compromised or not compliant, we just putting it off out of the Wi-Fi. But something that is interesting to me that I heard is that the coverage. So I guess a lot of when I speak to different friends of mine that works in different companies, there I hear that I don't have Wi-Fi coverage and so on. So I think the one of the crucial part when we're talking about enterprise Wi-Fi is that piece that you need to do some site survey. You need to do a proper planning, not only to ensure that users have good experience, but to ensure that you're not wasting money.
Yes, of course. And again, this is something that enterprise Wi-Fi really differs from the home deployments. Is that because when you have many access points, the automation becomes really important.
Yeah.
Because if you have hundreds or thousands of access points, then you're probably not going to go to each access point and change the parameters. You most likely what the current solutions are providing, you provide thresholds and guidelines in the configuration of the wireless controller, and then this is, by the way, the secret sauce, if you will, for every vendor. It's called the radio resource management algorithm.
Okay.
Nowadays, again, machine learning and AI algorithms are starting to step in so that they can provide better algorithms for managing the Wi-Fi, because that's the tricky part. It's not the cable.
Yeah.
It's a radio, that there are radio channels within a band. So even though it has worked today in this very spot, maybe something happens. Maybe somebody brings a device which is transmitting something in the same channel that you're using, which can wreak havoc, and you won't get any, because that's why I'm saying coverage is important, but it's not the single most important thing. You might have great coverage. I mean, my device might be receiving very strong signal from the access point, but the other important time is how much this channel is being used at this moment, because the algorithm that Wi-Fi uses, this is the same for home and enterprise Wi-Fi's, is contention based. So the multi-access is happening by all of the Wi-Fi hosts competing to win the contention, to use the channel so that they can send or receive data. So you can imagine if you have too active Wi-Fi hosts which are assigned to an access point, at some point, I mean, it's a limitation that you have to live with it. So, for example, and again, it's not an easy question to answer how many hosts you have to plan per access point. It depends how they're using the environment. I mean, I might have a host which is constantly uploading and downloading, or I might have 10 phones which are sitting on the table and sending small packets here and there. So it's the complexity comes from the many variables you have to take into consideration. And again, for an enterprise environment, if you have a good controller, if you have a good radio resource management algorithm, many of those variables can be resolved by just setting the guidelines and the thresholds in the radio resource algorithm when you configure it.
Yeah. Perfect. Very nice conversation. So I want to thank you for being here with us and sharing your thoughts about all those interesting things that are coming into the networking. Thank you all for watching. Follow us, subscribe us for more. We're going to get more diverse content on different topics. And have a nice evening or day.
Take care.
Thanks.